In part 3 there was a little bit correction in the question number 73, so kindly note that and then we'll proceed for the part 4 video. 73 question was vector A magnitude is 2, vector B magnitude is 3, vector C magnitude is 4, and the angle between B and C is angle between B and C is 2 pi by 3. Vector A is perpendicular to both B and C. We have to show A dot B cross C is equal to 12 root 3. Now see, A is perpendicular to B and C. So this will imply vector A is some lambda times of B cross C. So magnitude of vector A is lambda times of magnitude of B, magnitude of C, and it is then coming out to be because angle between them is 2 pi by 3. Magnitude is 2 lambda 3 into 4 and root 3 by 2. Now we can say that this will get cancelled with this. Lambda is 1 by 3 root 3. Now see, next we have to find A dot B cross C, which is equal to lambda times of B cross C dot B cross C, which is nothing but magnitude of B cross C square, which is lambda times of magnitude of B square, magnitude of C square, and sine square 2 pi by 3. That is 1 by 3 root 3, and magnitude of B square is 9, 16, and it is the root 3 by 2 square is 3 by 4, so it is going on 4, and this is nothing but turning out to be root 3, 12 root 3. That's what we want to prove. Now we have the question from question number 76. So this was the correction. I am writing correction to part 3 video. Now the line is 3 minus x upon 5 y plus 4 upon 7 and 2z minus 6 upon 4. We have to write the vector equation of a line. So we can write this as x minus 3 over minus 5, y plus 4 by 7, and z minus 3 by 2. So here A vector is 3i cap minus 4j cap and plus 3k cap. B vector is 5i cap plus 7j cap plus 2k cap. So the vector equation is R vector equal to A vector plus lambda times of B vector. Now we have 75, question number 75 also yet to do, so we have skipped the question number 75. Question number 75 is like this. We have the line 5x minus 3, 15y plus 7 and 3 minus 10z. We have read the direction cosine of the line. So if we take 5 common from here, so x minus 3 by 5, 15 common, so y plus 7 by 15, and 3 common means minus 3 common means so in fact rather than minus 10 common is z minus 3 by 10. So LCM of then 5, 15 and 10 is going to be 1, 3, 2 and 30. So dividing by 30. So x minus 3 by 5 by 6, y plus 7 by 5 by it is turning out to be 3, and then z minus 3 by 10 by So it is turning out to be 2 and it is turning out to be minus 3. Our direction ratio are 6, 2, minus 3. Their magnitude is 36 plus 4 plus 9, that is 7. So direction cosine are 6 by 7, 2 by 7 and minus 3 by 7. It is indeed is very good question to do. Now question number 77. Again we have the line x minus 2 by 6, y minus 1 by lambda and z plus 5 by minus 4. This line is perpendicular to the plane. We have to find the value of lambda. Now since it is the plane and the line is perpendicular, now see how we are going to calculate this. Now this is normal and the direction ratio of normal are here. The plane equation of plane is 3x minus y minus 2z is equal to 7. So direction ratio are 3 minus 1 and minus 2. Now this is normal vector and the line is again perpendicular to this plane. So this is how we are going to write, that is 6 lambda and 4. So they must be proportional. 3 by 6 is same as minus 1 by lambda, must be same as minus 2 by 4. So one can say that lambda is minus 2. Value of lambda is minus 2. So in that way we can calculate the value of lambda. So now we have another question. 78 question is find the distance between the point this and the point of intersection of the line and the plane. Minus 1, minus 5 and stand, this is the point P and here is the line x minus 2 by 3 and y plus 1 by 4, z plus 2 by 2. Let us take any point on the lambda. X 3 lambda plus 2, y is equal to 4 lambda minus 1, z is equal to 12 lambda minus 2. Now the equation of plane is x minus y plus z is equal to 5. So they must satisfy this plane. 3 lambda plus 2 is 4 lambda plus 1 plus 12 lambda minus 2 is equal to 5. Now let us simplify it, and this will get cancelled with this, and this is nothing but 8, that is 11 lambda is equal to 4, lambda is equal to 4 by 11. Now one can write this as x is equal to 3 lambda plus 2 means 12 by 11 plus 2, 11 plus 2, that is 22 by 11, that is nothing but 34 by 11, and let us check it further. 3 lambda plus 2, 4 lambda minus 12 lambda minus 2. The equation of plane is like this. Now 3 lambda and minus y means minus 4 lambda plus 2 and 12 lambda minus 2, 11, and okay, that's okay, and y is equal to 4 lambda minus 1, that is equal to 16 by 11 minus 1, that is turning out to be 5 by 11, and z is equal to z is nothing but 12 lambda minus 2, that is nothing but 48 by 11 minus 2, that is 48 minus 22 by 11, and it is turning out to be 26 by 11. Now if I take this my point Q as 34 by 11 and 5 by 11 and 26 by 11, so and the point P is given, so use distance formula to get it. So use distance formula, PQ distance can be calculated. Now we have question number 79 is 79 is find the equation of a plane which passes through this. Now 3 2 0, and the plane is containing the line. The plane is containing the line. Now it means that this plane is passing through 3, 6 and 4, because equation of the line is x minus 3 by 1 and z minus 4 by 5, and the plane is also passing through the point 3 2 0. Now can we connect these two vectors AB? So my normal vector in this case will be AB vector cross B vector, and here B vector is I cap plus 5j cap, and it is nothing but say it is 4, z minus 4 by 4, that is 4k cap. Now AB vector turning out to be 0 I cap minus 4j cap minus 4k cap. So now here if I take R minus A vector dot AB cross B, and I will take my A vector as I cap plus 2j cap plus 0k cap. So equation x minus 3, y minus 2, z minus 0, and AB cross means 0 minus 4 minus 4 and 1 5 4. So this we will get the equation. And the 80th question is there are two lines. R vector is equal to I cap plus j cap plus k cap plus lambda times of 2i minus 2j plus k cap. This is line 1, and line 2 is R vector 2i minus j minus 3k cap plus mu times of I cap plus 2j plus 2k cap. Obtain its equation. The line is passing and perpendicular to both these two lines. Line is passing through 2 minus 1 3. So equation of such line, if I take this as vector A as, so such line, if B1 vector is 2i minus 2j plus k, and B2 vector is I plus 2j plus 2k. So such line is R vector is equal to A vector plus lambda times of, we can write this as lambda times of B1 cross B2. So you will get this equation. Now we have another question, that is question number 81, and it is somewhat like this. We have two lines, x plus 1 by 3 by 5, z plus 5 by 7 is equal to, let it be lambda. This is line 1, and line 2 is x minus 2 by 1, y minus 4 by 3, z minus 6 by 5. We have to prove that these two lines intersect and to find point of intersection. So from line 1, x coordinate is 3 lambda minus 1, and from this line, second line is x coordinate is t plus 2. Equate them. So 3 lambda minus 1 equal to t plus 2 minus t equal to 3. This is the first equation. Now for y coordinate 5 lambda minus 3, and from the second line 3t plus 4, equate them. Lambda minus 3t is equal to 7. This is second, and the third one is z is equal to 7 lambda minus 5, and z is equal to 5t plus 6. Equate them. Minus 5t is equal to 11. Now what we are going to do, let us multiply 1 by 3 and then add, subtract rather than this, 3t is equal to 9 and 5 lambda minus 3t is equal to 7. So let us subtract it. It is minus 2 lambda is equal to minus 2. I hope, sorry, plus 2, and lambda is minus 1. Now substitute in any of the line, and that is 3 lambda minus t is equal to 3. If I substitute here, so minus 3 minus t is equal to 3. So this will imply t is equal to minus 6. Now it should satisfy equation number. Now what is lambda? Minus 7 Oh my god, here is some mistake, that is we have multiplied it, it has to be 9, and if we subtract it is turning out to be 4 plus 1 plus 4, and lambda must be equal to 1 by 2. So that is the mistake. So let us simplify it further. We had done this mistake, so now let us clarify. So 3 by 2 minus t is equal to 3, t is equal to minus 3 by 2. Now 7 lambda minus 5 t must be equal to 11. Now 7 by 2 plus 15 by 2, that is 22 by 2 equal to 11. So hence lines intersect. Now point of intersection. Points of intersections are I am going to take a lambda as 1 by 2 in any of this. So x as I got 3 by 2 minus 1, that is nothing but 1 by 2, and or y will be equal to 5 lambda minus 3, that is 5 by 2 minus 3, I think it is minus 1 by 2, and the z coordinate was 7 lambda minus 5, that is 7 by 2 minus 5, and it is turning out to be minus 3 by 2. So points we have calculated. Now next we have question number 82. We have the line x plus 1 by 7, y plus 1 by minus 6, z plus 1 by 1. This is line 1. Its a vector, a1 vector is minus I cap, minus j cap, minus k cap. Its b1 vector is 7 I cap, minus 6 j cap, plus k cap. Now we have line 2, x minus 3 by 1, y minus 5 by minus 2, z minus 7 by 1. Its a2 vector is 3 I cap plus 5 j cap plus 7 k cap. Its b2 vector is I cap minus 2 j cap plus k cap. We have to find the shortest distance. So shortest distance between the line is a2 minus a1 vector dot b1 cross b2 upon magnitude of b1 cross b2 and whole mode. So we can use this formula and we'll get the result done. Now we have one more question here. Question number 83 of this. Equation of plane which passing through 1, minus 1 and 2 and perpendicular to both planes. What are the planes? 2x plus 3y minus 2z is equal to 5 and x plus 2y minus 3z is equal to 8. So here n1 vector is 2i cap plus 3j cap minus 2k cap, and my n2 vector is I cap plus 2j cap minus 3k cap, and a vector is I cap minus j cap plus 2k cap. So equation of such plane is r minus a dot n1 cross n2 because perpendicular to both the planes. Now here equation will be like this: x minus 1, y plus 1, z minus 2, and 2, 3 minus 2, and 1, 2 minus 3. Solve this, you will get the desired result. Now we have question number 84. Now it is the same, and now I am discussing few of the questions of probability. Now if you see the probability based theorem questions of these papers, if I do consider this, see these papers, you will find all these questions. You can see our video section and subscribe to our group and video section. In our video section all the base theorem questions are there and the probability distribution, so you can easily get the solution of those questions. Thank you.